Let's continue on the case study 2. So again, don't skip the description, pay attention and understand your data. Okay, so let's take a look. So basically, you're the dean of the math department, so that's nice. And you receive so many applications and you only want to admit those students who will successfully reach a GPA of 3.0 for the first year. So in order to predict the student GPA, you considered a few factors. So first, the SAT math score, the SAT reading score, and gender. Okay, so basically we have a few variables. So we have GPA, and then we have SAT math. See, read here, SAT math here, it's in hundreds. For example, if you take a look at data, look at the first guy. The first guy have a GPA 1.97, and its female equals to 0 means this is a guy. So this guy have 300 on SAT read, 246 on SAT math, and the SAT INT interaction is basically a multiplication of the SAT math and the SAT read. Okay, so for question 16 and 17, it wants you to compare the mean GPA for male versus female. So when we are comparing two samples, you have to think about the type of test you can do. So we have two sample tests here, and then you think about whether you should do an independent t-test or a pair t-test. So pretty obvious here, we should do an independent t-test because the female students and the male students here are independent individuals, and we don't have a one-to-one relationship between these students. Okay, so in order to do a two-sample independent t-test, so let's do analyze compare means independent sample t-test. So the test variable is the GPA because we want to compare the mean GPA of grouping by female. So female, so for example, if we use group 1 as female equals to 1, group 2 female equals to 0, this means what? This means I put the female first and then male second. Okay, so group 1 is female, group 2 is male. So again, why am I using 1 and 0? This is because that's how we code in the data. If you put F or M here, it wouldn't work because, again, it has to be exactly like what they coded in the data. Okay, so let's do continue. Let's do OK. So we get a bunch of tables. So the first one asks you what's the p-value if you want to test whether there's any difference between male and female. Again, keyword any difference, so two-sided test. So let's take a look at the results. So first you have to decide whether to look at equivariance or not equivariance. You can look at the standard deviation. So for standard deviation, 0.61 over almost 0.4, so smaller than 2, equivariance. You can also look at the Levene's test. Levene's test has large p-value. We're not rejecting, meaning they have equivariance. So equivariance, what's the p-value? P-value is 0.066. That's exactly what we're looking for, C, okay? And then it asks for the confidence interval for female versus male. This means what? This means we're looking for the confidence interval of female minus male. So the confidence interval here is minus 0.03 to 0.9, okay? But just to make sure, which one did you put first? So we put female first, then male. So we have female minus male belongs to minus 0.3 to minus 9 to 0.9, which is exactly what they are looking for, okay? For example, if they say male versus female here, then we should choose A. So make sure you know the subtle difference. So the order matters here. Because if you look at A and B, the only difference is the sign flipped. Okay, now let's move on to regression. So for the first regression, they say we are only consider SAT math as the predictor. So for every model, every regression model here, they would give you a clue. For example, in this, it tells you that the F statistics is 22.63693. So this is very nice because it gives you a hint to verify whether you have the correct output. So first, let's run the model. So model 1. So we're going to analyze regression, linear regression. So just follow this equation here. So GPA as y, SAT math as x, okay? And then let's do okay. So we have this table here, and then first let's verify the hint. So F statistics, I have 22.693. Yay, it's the same as the hint. So it's good. Now you can make sure you have the correct output, okay? Another thing I suggest you to do is to change, on the left, change the title here, because you can have so many regression model here and you would forget which model this is. So maybe we can change this to model 1. Or you can say question 18, depending on your habit, which one makes sense to you, okay? So first, it's the estimated linear equation. So basically, we need to find the value for beta 0 and beta 1 and plug in there. So coefficient table. So from the coefficient table, we know that beta 0 is 1.552, and we have 0.255 for SAT math. So very easy, we choose B. And then 19 asks for the correlation. So correlation is just R, which is in the model summary table, 0.747. If they ask you what's the percentage of variation can be explained, that would be R squared. But here it only asks for correlation. And then question 20 asked for what's the 95% confidence interval for the mean GPA that is associated with a score of 500 on the math portion. So again, read the question. We are looking for the confidence interval. For what? For the mean GPA. So for a group what? A group who have the math score 500. Okay, so this is a prediction question, right? We want to know the confidence interval for the group that has math equals to 500. So in order to find the confidence interval, what do? We use the save option, right? So let's redo the regression again. Analyze, compare means, regression, linear regression in the save option, okay? So save option, so you can also just select that because sometimes they ask for predict value. In this case, they ask for the interval. So mean, individual. Here it asks for mean GPA, okay? And then 95%, that's the default. But sometimes they would say 98%. So again, pay attention to the details in the question. Continue, and then let's do OK. So we get the table again. So again, you have another regression. You can change it to model 1 or something. Or you can even delete it if you think this is useless afterwards. But the important thing is we want the saved value, right? So if you check your data, we have saved a few new columns. So the PRE one is the predicted value. Again, if you want to know the specific meaning of each column, switch to variable view. And then in the label part, it has a detailed explanation of what each column represents. Okay, now we just have to find somebody who scored 500 on math. Again, 500 here means SAT math equals to 5 because here 1 means 100. Okay, so we have to find somebody who has an SAT math equals to 5. Oh, here it is, but maybe suppose, for example, during the exam it's not that clear. What you can do is you can highlight the column of SAT math. There is search option, so find 5, then find next. Oh, this is not very smart. Oops. Maybe find 0.00. Here we go. So it highlight this row. Oh, so case 13. And then we just have to read the confidence interval. So the confidence interval is LMCI to UMCI. So we have 2.6 to 3.02, which would be D. Okay. Yeah, if they ask for prediction interval for one individual, that would be from 2 to 3.6. Okay. So that's 20. 21 asks you what's the estimated effect of mean GPA of an additional 50 points. So basically saying if you have two guys, one guy has 50 more points on SAT math, what's the difference of the GPA between these two people? Okay, so basically you're looking for the difference between mu GPA given SAT math plus 0.5. Again, 0.5 is because 50 means 0.5 in the scale here, minus mu of GPA given SAT math. And we just work with the equation a little bit, and we would see this equals to what? 0.5 times beta 1. And beta 1 is 0.255. So here we have 0.1275. Okay. Question 22 asked for the residual plot. So the residual plot is a scatter plot of y is the z resid, x is the z predict. So we have to run the regression again. So let's run the analyze regression, linear regression. So in the plots option, so we want z predicted and z residual as x. Okay. Oh, whoops, that was wrong. So, okay. So I basically z resid as y, z predict as x. Okay. So you can also check that sometimes they ask for it. So I would say the pretty routine things you need to check includes the plots option, check these guys to get the plots, and in the save option, check these guys. Okay. But we have already saved these guys once, so you don't want to make your data look so ugly. So let's uncheck these. Then let's do OK. So, okay, you get all the tables again. So again, if you can maybe name this as, so here we have question 22. So you can say question 22. So be easier for you to organize. And this one is for question 20. Okay. So for question 20, we want the residual plot. So PP plot, this is a residual plot, which looks like B. Okay, which looks like B. Okay, so that's first model, pretty easy, only one predictor. So for the second model, they want you to use a large model which has 4 predictors: SAT math, SAT read, female, and the interaction between the math and read. So again, they give you a clue. The clue is that the standard error is 0.3125. Okay, so let's run the model first. So let's do analyze regression, linear regression. Okay, so we want 4 predictor, right? SAT math, SAT read, female, and the interaction. Okay. We have saved the plots. Okay, that's good. And again, I think often they would ask for the prediction question, so maybe just save this as well. So save the predicted value. Continue, and then let's do OK. So let's first verify the hints. So the standard error. So standard error 0.3125. Okay. Sometimes you don't know where to find the standard error. What you can do is kind of compare this number to the whole, to all the tables. If you can't find a single number equals to 0.3125, something must be off. Okay. So question 23 asked for the R square. So R square is in the model summer table, 0.75, easy. 24 asked you to estimate someone who has female, which means female equals to 1, 5 on the on both portion. Sorry, oh, this should be wrong. So we should have 5. 500 means 5. 5 on SAT math, 5 on SAT read. Okay, so we have already saved the prediction. Okay, now we just have to find somebody who is female and who has SAT math and read equals to 5. So okay, we can use SAT read as the search key. let's do find 5.00. Okay, so it gives me this case, but for this guy, the SAT math is 3.76, which is not what I'm looking for. So let's look for next one. Find next. So this is female equals to 0. No. SAT math and SAT. Okay, I'm just gonna try this again. Find next. The search string. What do you mean? Do 5. This is weird. Maybe I should use SAT math. SAT math equals to 5.00. Find next. Oh, I don't have a case. I don't have a case that fits the description here. So what you can do is you can just plug in all these values into the equation. So basically SAT math should equals to 5, SAT read equals to 5, female equals to 1, and then the interaction equals to 5 times 5 equals to 25. Okay, so plug in the values into the equation and calculate by hand. Okay, so sometimes you might not be able to find the exact cases, so in that case you have to compute by hand. And you can read the beta 0, beta 1, 2, 3, and 4 from the coefficient table here. Okay, so these are the numbers. So that's 24. 25 asks you to test whether the effect of SAT math depends on SAT read. So whether SAT math depends on SAT read. So we're looking for whether two predictors are affecting each other. So if you see this kind of question, this is testing whether the interaction term, this term, is significant or not. So basically, we have the H0 is beta 4 equals to 0, and HA is beta 4 doesn't equal to 0. Try to understand why I reached this conclusion based on this sentence. Okay. So in order to test beta 4, we just look at the coefficient table, right? The last row, this is corresponding to beta 4. So for the SAT interaction, I have a p-value for 0.597. 0.597, that's it. So here we are doing a two-sided test. For example, if they ask, does the effect of SAT math positively depend on SAT read or something like that, then in that case, you have to divide the p-value by 2, okay? Okay, 26. 26 asks you to test whether the mean GPA is higher for female than for male. So we're comparing the GPA between male and female after counting for these variables. So basically we're testing the beta 3, right? So if beta 3 equals to 0, it means male and female have similar GPA after counting for these variables. If beta 3 is larger than 0, it means female has higher mean GPA. Okay, so these are the hypotheses. So we're testing beta 3. So when we're testing beta 3, we look at the row of female. We have a two-sided p-value 0.482, but we are looking for a one-sided p-value. So 0.483 divided by 2, and we get this. Okay. 27. 27 asks you which factors appear to be significant. So we're saying that first we look at ANOVA table, right? If ANOVA table have small p-value, which it is, in this case, we say some factor must be significant. And then we look at the coefficient table to find which ones of them are significant, right? So, but the weird thing here is that even though ANOVA table shows significance, but the coefficient table, all the p-value are large, okay? So this happens because some of our factors, some of our predictors are highly related. So this is what I call multicollinearity. So when you have some of the variables are highly related, they kind of like work against each other. So we have large p-value for everybody, but actually some factors should be significant. So if this happens, you should select some factors are significant. So because F table significant, it means some factors are significant. Even though none of them is significant here, the problem here is the variables we have here are not appropriate. If you, for example, delete SAT Math or SAT Read, you would see significance there. Okay, so again, in summary, if you see that F table significant, then you say some factors appear to be significant. If the ANOVA table have large p-value, you say no factor appear to be significant. Okay. And this one talked about the normality and constant variability. Well, it's not kind of even too much related. But even though here, the PP plot looks pretty good. So I would say no violation of normality assumption. Equivariance is not bad. Most points are between -2 and 2, and it's pretty uniform. So, and again, if you see this kind of question, is more about the ANOVA table. Okay, so the last 3 questions ask you to compare model 1 to model 2. Okay, so this is what I call the extra sum of square F test portion. Okay, so basically we have a full model and we have a reduced model. So in this case, it's easy. We only have 2 models, so you don't have to choose which ones to compare with. Okay, and then how do you decide whether model 1 is full or model 2 is full? This is easy here because the larger one is full model. So the model 2 is larger because it contains 4 predictors. Model 1 only contains 1 predictor. So we have full model is model 2, and then we have reduced model is model 1. And the null hypothesis, basically we're testing whether beta 2 to beta 4 equal to 0, and that's the alternative. So it asks for 4 things, the SSR and the degree of freedom for both models. So let's take a look at the reduced model first. So reduced model is model 1. Model 1 is where, for question model 1, so model 1, we have SSR represents SS residual, so 2.590 and 18, so very easy. Look at the residual row and read these 2 numbers. Okay, that's for the reduced model. For the full model, it's the model, so I forgot to change this. This should be model 2. So model 2, the SS residual 1.4 and degree of freedom 15. So B it is. And then 29 asks you for the test statistics. So the test statistics is basically the F ratio here. Again, remember this formula, okay? So basically just follow this and then you will get this number. And also remember the degree of freedom. So F 315 in this case. And that's everything, okay? Again, just take a look at the structure of the exam. You would see that it's highly predictable. So anyway, that's everything for the second data set.